We are going to see about how to convert the given PDA into context free grammar and then converting of context free grammar into the PDA. So these the things in this class we are going to discuss. So as like finite automatas, PDS is also of two types. Uh, Finite automatas are of two types. How many? What are those types? What are the different types of finite automatas? Deterministic finite automata and then non-deterministic finite automata. In the same manner, there are two types of PDS are there. Push down automata, deterministic push down automata and then non-deterministic push down automata. So the name itself suggesting like the deterministic, we can determine. So if for the present state, what will be the next state? We have only one choice, we can determine that one. So that is called as the deterministic. And whereas non-deterministic in the sense, for the present state, what will be the next state, we can't decide. So there, that is called as non-deterministic. So non-deterministic PDA and deterministic PDA. PDA is nothing but push down automata is nothing but the FA with extra memory, stack memory is called as push down automata. There in finite automata we have 5 tuples. In push down automata we have 7 tuples. All this explained in the last class. So deterministic PDS are very useful in programming languages. So parser used in yet another compiler AAC that we will discuss are deterministic PDS. So now we'll see one example designing of PDA for the language W power R. So here W represents the string, W power R in the sense the string should be in the reverse order, and that such that the W is belongings to the sigma equal to A plus B whole star, which means it may consist of A's and B's, combination of A's and B's. So whenever we had given a string, there should be a reverse of the string should also be presented. A plus B whole star. So we may take nothing also. A whole star is presented, no? So we may take nothing also, or else we can take with only A or only B or combination of A's and B's we can take. So this is the solution for that one. Initially the stack consisting of Z0, as we already know that one. So already I discussed and I told that the initial symbol, the stack symbol of the stack contains Z0. So which means the stack did not have any symbols on this stack. So initially we may read A or B. So the strings we can form with either A plus B whole store is the input. So we can have the strings the start that may start with either A or it may start with B. So if you give A or B, so already in the stack we may have Z0. So initially first time we are reading A or B. So simply what we will do, we'll push that one onto the stack. So see here, if it is A readed, before that Z0 is the only symbol presented in the stack. So stack is empty. Now once it reads the A, we'll push that A onto the stack. Initial one. So we don't know reverse of the string. Just we read the string. Now we are reading the string. Once if the string has been completed, we have to change the state and then we have to check whether the given string reverse is presented or not. So here A Z0. So simply we are pushing A onto the stack. So on the top of Z0, A will be presented. Same like for B also. So string may starts with A or B. A plus B antunam kada. So string may starts with either A or B. So now B Z0. B we are pushing onto the stack. Now initially the stack consisting of Z0. Now it is converted to B Z0. Okay. Then after A we may get A or B. See here this transition, third one. After A we may get A in string, or after A we may get B. Even simply we'll push on A also, B also onto the stack. Same like for B also, after B we may have A or B. Simply we'll push that one onto the stack Q0. Okay, fine. All the things we are pushing onto the stack until unless it is in Q0. But now we'll getting the reverse of a string. So which should be, what is our language? String, and the reverse of the string should be presented. W to the power of R. So whenever we are taking W, all the inputs we are pushing onto the stack. Fine. But when we got once the reverse of the string is presented or not, we have to check. For that one, we will change our state Q0 to Q1. Here, if A after A is presented, we are performing pop operation. For A equal, there should be a in reverse. ABA, reverse same avutundi, same ABA. So for A, it should be A. For B, it should be B presented. If it is A with A, we'll perform the pop operation. If it is B with B, we'll perform the pop operation. Same like in Q1 state also, if it is B with B mapping, we'll pop the operation. If A with A is mapping, we'll perform the pop operation. Finally, here no symbols are presented in the tape and stack also becomes empty. So this is the acceptance by empty stack method. So we can check the string acceptance in two ways. One is acceptance by final state. One is acceptance by empty stack. Here we are checking acceptance by empty stack. So here the stack becomes the empty. So we reached the final state. So this is how we will construct push down automatas. Here input, and previously what is the status of stack, and now what operation we are performing onto the stack, push operation or pop operation. Push operation means we'll have the symbols, whereas pop operation in the sense we'll have epsilon symbol. Whenever in PDA, if we have epsilon symbol which represents that we are performing the pop operation. Same the things, whatever the things I had explained, here we have transition function. So that is example of constructing of the PDAs, push down automatas. Okay. In the next topic, we are going to see the construction of a PDA from context to free grammars. So we have context to free grammars. The rule of context free grammar is production rule. Production rule of context free grammar. Production rule of context to free grammar. Production rule of context free grammar. Anyone? A tends to alpha is the production rule of the context to free grammar. Now we are converting the productions of the context to free grammar PDA from the context free grammar. We have production rules. Now we will convert that production rule into PDA, push down automata. So there will be an equivalent push down automata for a context free grammar. Vice versa is also possible. For every context free grammar, there will be an equivalent push down automata. So this vice versa will be presented. Now first we will see construction of PDA from context to free grammar. So first the thing, for getting of PDA from the given context to free grammar, we should convert all our productions into the GNF form. GNF form in the sense Grayback normal form. So already we had seen that context free grammar consists of two normal forms, Chomsky normal form and then Grayback normal form. So in the Grayback normal form, the production rule should be in the form of S tends to, it means non-terminal, tends to a terminal followed by any number of non-terminals, or non-terminal tends to terminal. So these two types of productions can be presented in the Grayback normal form. If the given context-free grammar is not in the form of Grayback normal form, so we have to convert that given production of the context-free grammar into GNF. So already we had seen the procedure how to convert the given context-free grammar into Grayback normal form. So that the things we had seen already in the previous classes. So now after converting the Grayback normal form, so now the PDA will have only one state Q, that is Q, and the stat symbol of the grammar will becomes the stat symbol in the PDA, and all the non-terminals of the context-free grammar will be the stack symbols of the PDA, all non-terminals, capital letters, and all the terminals of context-free grammars will access the input, that is equal to sigma. All the terminals will be acted as the sigma, and all the non-terminal will be acted as the stack symbols, gamma. So stack symbols. Okay, for each production in the form of A tends to terminal followed by non-terminal, then we had to make a transition of del of q comma a equal to q of x. Whereas for each production, if the production is in the form of A tends to A, then we have to make a transition of del of q comma a comma capital A, that is equal to q comma epsilon. So these are the two major steps. We have productions in the form of A tends to AX, or we have productions in the form of A tends to A. If it is in the form of A tends to AX, so we have to convert that one into this transition. So del of q comma small a comma capital A is equal to q comma x. If it is production is in the form of A tends to A, so then we have to make a transition of del of q comma a, that is equal to q comma epsilon. So now we'll see the example problem for converting of the given context free grammar into push down automata. So here this is the production rules. So S tends to A tends to AS or BS or A. These are the productions given. So already this grammar is in GNF, Grayback normal form. So no need to convert, no need to follow the step 1. See here, what is the step 1 for converting the PDA from the given context free grammar? Convert the productions of the context free grammar into GNF. First, all the productions we have to convert into the GNF. So GNF production rules, you know that one. Right hand side, terminal followed by any number of non-terminals, or only single terminal should be presented. So for this purpose, if we have to check whether all the productions is in the form of Grayback normal form or not. So now the given grammar is in Grayback normal form only. So now no need to perform the first step. We'll go for the next step. The start symbol of the grammar, here start symbol is yes. The start symbol of the context free grammar will be the start symbol in the PDA. Okay. Next one. For each production in the form A tends to AX, terminal followed by non-terminal. So if such a type of productions are presented in your grammar or not, check it one. So after terminal, is there any non-terminal in the given productions? Yes. After terminal, we have non-terminals. First production, even second production, A tends to AS. There also terminal followed by non-terminal is presented. Even in third production, A tends to BS. Here also we have terminal followed by non-terminal production. Now all these productions has to be changed to the transition function. So by using this formula, say step 5. Here It is in the form of terminal followed by non-terminal. So for such type of productions, we have to use this transition formula. So del of q comma a is equal to q comma x. So now here q comma a comma x. So q comma a comma will present same as it is. Here capital A in the sense left hand side symbol. Here in S tends to a left hand symbol side symbol is yes. So that is equal to some state q comma x. X means there are after terminal whatever the symbols are presented that will be treated as x. So after a here two double a's are presented. So this double a will be the transition function. So the first one completed. Same the thing for all the productions which are in the form of A tends to AX. Terminal followed by non-terminal. For all these productions, we have to apply step 5. So how many productions are there in this form? A tends to AX. First one S tends to AA. Second one A tends to AS. Third one A tends to BS. All these three productions has to be converted into the transition function by using this formula. After completion of the conversion from A tends to AX production, we may have one more production form, that is A tends to A, that is right hand side single terminal may present. For example, here we have A tends to A, capital A tends to small a. So if the production is in that format, then we have to write del of q comma a equal to q comma epsilon. So here q comma a. So we have q comma a. So here small a, capital A place we have capital A, that is equal to q comma epsilon. So it will convert into the pop operation. If epsilon is presented, that is pop operation. If the symbols are pushed, then it is push operation. So all these productions has been completed. So likewise we have to apply for all the productions. So compulsory we may have productions in the form of either S tends to A tends to AX format or A tends to A format. So we have to apply this step 5 and step 6 for all the productions accordingly. So if it is only terminal on the right hand side, you have to apply step 6. In the right hand side, terminal followed by non-terminals, then we have to apply the 5th step. If the production form is in the form of A tends to AX, terminal followed by non-terminals, then we have to follow the step 5. So this is how we will convert the given context-free grammar into PDA, equivalent PDA. And the next one, constructing of the context-free grammar for given PDA, reverse one. As I already told that one, we have an equivalent context-free grammars for the given PDAs, and we may have equivalent PDAs for the given grammar. So first, to convert the pushdown automata to, so to convert the PDA to context-free grammar, we have to use the following rules. So the productions for start symbol are given by S tends to Q naught, comma Z naught, comma Q for each state Q in capital Q. And the rule 2, each move that pops a symbol from stack with transitions as del of Q comma A comma Zi equal to Q1 epsilon. And then in R3, each move that does not pop all the symbol stack within the transition as del of Q comma A comma Z naught equal to Q comma Z1, Z2, Z3, Z4. So and then if del of q comma a comma z not equal to q comma z1 z2 z3 z4, so del of q comma a comma z not equal to q comma z not comma qm tends to a of g1 comma z1 comma q2 and q2 of z2 comma q3 q3 of z3 comma q4 q4 of z4 q5 and so on up to the last one q4 z4 tends to q5. So likewise we have to convert the given constructing. So we'll see one example. So given the equivalent context free grammar for the following PDA, m equal to q1 q2, so we'll see with example. So the context free grammar for del of q1 comma z not. So the context free grammar for del of q naught comma b comma z naught equal to q naught comma z z naught. So we are pushing same for context free grammar for del of q naught comma b comma z naught equal to q naught comma z z naught. We are pushing z onto the stack and q naught comma z naught comma q naught tends to b of q naught comma z comma q naught z naught q naught and del of z naught comma q1 equal to b of q naught comma z naught comma 3 and q naught comma z naught comma q1. So likewise we have to apply for all these productions. Then the context free grammar for del of q naught comma epsilon comma z naught equal to q naught comma epsilon by using the second rule, and by using the third rule del of q naught comma b comma z naught equal to q naught comma zz is obtained by using the rule 3. Here we had given rules no for converting, that is nothing but procedure r1 r2 r3 rules. So we have to apply all these three rules. So then finally we'll get this solution. These are the productions. All these are the productions, stat symbol of the grammar and remaining productions. So this is important topic, converting PDA to context free grammars and context free grammars to PDA. So the next one, two stack PDA. Before that we have only one stack PDA. So to store more number of symbols, to have extra memory, we are using extra element called stack. FA with stack is nothing but push down automata. So in that one also, instead of having one PA stack, we'll have more stacks. So that is nothing but one more stack. So we call it as two stack PDA. Here extrally we'll add two symbols only. Previously PDA consisting of 7 tuples q sigma del q naught and f. These are the common FA to PDA. Now for general PDA we have two more symbols also, gamma and then z naught. Z naught represents the empty state, initially the stack consisting of z naught as the symbol, top of the stack symbol. So that is z naught. Here now we are taking one more stack, same two symbols it should consist. Gamma consisting of the stack symbols and Z0 is the initial state. If you take both Z0, Z0, which initial state it is, either stack 1, stack 2, we may get confusion. So that's why here we are taking Z1 and Z2 as the initial values on the stack. Same gamma also we have stack symbols, gamma, gamma 1, or gamma 1, gamma 2 also we can take for stack 1 and stack 2 symbol storing, for storing of those symbols. So that is about 2-stack PDA. So design a 2-stack PDA which accepts A power n, B power n, C power n. So how many number of A's are there, that many number of B should be there, and that many number of C should be there. We cannot build this one by using finite automatas because remembering is not presented. But whereas in the PDA we can construct. But even to you by using 2-stack PDA, it is very easy. So initially we have A, Z1, Z2. Stack symbol from the first stack and stack symbol from the second stack. So we'll push this one onto the stack. A Z1 comma Z2. Same AA Z2. It will becomes AA Z2. BA Z2. It will becomes AB Z2 and so on. So likewise we can construct a 2-stack PDA for the given problem. So it is one more example. So this is about the 4th unit. This is about the next topic.